to help make these kind of conclusions. All right. The other kind of post-hoc test that we can use, which isn't mentioned in these red slides, but which is mentioned in the other PowerPoint, and I don't think it's going to let me switch over. Hold on a second. Okay, so poof, magically I've switched over to our other PowerPoint. But some researchers really don't like this test, so they won't even tell you about it, which is what happened with the guy who did the red slides. But another kind of post-hoc option we can do is called an LSD, or Fisher's Least Significant Difference Test. So this one really is pretty flexible. LSD will help you remember that people tripping are into all kinds of things and anything goes. And it will help you look for differences, but statistically it's not as rigid or restrictive as the others. So it can work with unequal sample sizes. And I'm not opposed to it altogether, but I would steer you guys towards Scheffé just because less people are going to have a problem with it. Just like some people have a problem with recreational drugs, may not be good for you. LSD will do the job, but it may not be your best test. So I would say this if you're doing stats for me. If we've got equal sample sizes, use Tukey. If we have unequal sample sizes, use Scheffé. All right. LSD is not awful, but it's also not great. Now, again, here what I can show you for the last 2 minutes we've got is kind of a walkthrough. If we were running this test in SPSS, and we wanted to look at the comparison between 3 groups, if we find a significant F statistic, then we've got to run post-hoc tests. If we find a non-significant F value, stop. You don't have to do any post-hoc. And so here is an example of what it would look like in output, and then again in the next video I'll show you how to calculate it. If after we got our F value, which would be in a different table than this, we ran our post-hoc test, here the one the researcher used was LSD, it would show us in the particular example which groups differed from each other. So in this particular example, we had the amount of time that people were studying, and then it was looking at the outcome of their grade point average. So we had people who studied a little a week, people who studied more per week, and people who studied the most per week. What it does then is look at the comparison between each pair to see if it's significant. So in this case, between the people who studied a little and a little more, we found a mean difference. This is negative because the first group had lower grade point averages than the second group. So we see that significance marked here, and we could say, yes, that pair's different. Then we could look at people who studied just a little versus the most, and we also find a mean difference. This group did worse than this group on their grade point average, and that was also significant. The last pair, between the middle and most group, all right, did show a little bit of a difference, but it was not significant. So there wasn't a difference in grade point average between people who studied more and people who studied a whole lot. Now, I would like to say that probably